Okay, everyone, let's give a couple more minutes for everyone to join in. I'm really excited by today's talk. This is one of my, he doesn't know, but it's one of my idols. I have been listening to Azure DevOps for a long time. So I'm really excited to have him here talking us about Blazor. That is actually our new crush. As you guys know, we have never been a web developer. We have always doing Xamarin and WinForms and WPF until Blazor. Blazor is the one, I will say, the one framework that has brought us over to the web part, and we are really excited about it right now. We have been in, like I think that 2 years ago, we started with Uno because we were actually more familiar with XAML, but when Blazor came up, we just completely moved. So as always, next month, I think we're going to be talking about Avalonia, and with that, we're going to cover everything that we want for the .NET cross development. We already talked about Uno, we talked about Maui. Today, we're talking about Blazor, and with Avalonia, I think that we closed the 4 biggest players on the .NET cross platform. Besides that, as always, follow the .NET blog. We have here a really good set of articles, especially I want to point 3. I want to point the Microsoft build that is coming. I think that right there is where Maui is going to become GA finally. I think that that's coming here in build, finger crossed. And right now we already have the release candidate too. So it's even coming with a lot of Tyson support and a lot of great things there. So please follow that closely. Net 7.3 preview 3 is already there. I feel like next 6 just came up, and right now we are already in next 7 with a lot of great things, CHAR 11. And again, there are a lot of things, great things coming soon. I want to introduce Jeffrey Palermo. He's the Chief Architecture of ClearMeasure, a software architecture company that empowers a client's development team to be self-sufficient, moving fast, delivering quality, and running their system with confidence. Jeffrey has been an MVP since 2006, and he has a lot of conferences, a lot of books, and a lot of great information, especially about Blazor. I'm always following to see what's coming up about Blazor. Please also follow Architecture Tips for ClearMeasure. They have a lot of great information about circuit tracking, about Blazor architecture, about DevOps. So those really, really great information. Besides that, I think we're going to be doing a middle of the next month, another quick meetup where Jose will be presenting his experiment on Entity Framework, Sync Framework. So that's a surprise that he's building. And that's it. Jeffrey, I want to, as you always say on your podcast, ask you before we start into any other content, like, can you talk us a little bit about your highlights and your high points that have led you to the position that you are right now and everything that you have been doing in the .NET community?
Sure. Well, I've been programming for money since I was 18 years old. I was one of those odd kids when I was 15 that actually had my own web page. Shoot, I was actually odd for having my own email address. Since 2013, I've had my own consulting company, ClearMeasure. We're a software architecture company, but interestingly enough, we just got hired to modernize or to help their team modernize an application that I wrote when I was 18. So it was for a school district in Texas, and so that's kind of interesting. Let's see. I graduated with a bachelor's degree from Texas A&M University. I went there for the military academy. Started in the Air Force and kind of finished joining the Army Reserve. I really went deep into .NET programming, like deep, because the Army sent me over to the Iraq War in 2003 and 2004. And, there were certain times where we were just waiting between the intense times. There was times where we were just waiting, and I brought some .NET books, like the big 900-page ones at the time, and I read every single page and practiced a whole lot. I purchased a laptop computer, a Dell laptop computer from a computer shop in Kuwait City, and I found a way to get there. And so programming has kind of started out as my hobby, and now I've made a living from programming. It's really fun. And now I have a high schooler, a middle schooler, an elementary school kid, and trying to see which one is actually going to find the love of programming. But I've also found that I love to teach. And so ever since I was in 8th grade, I've gotten on stage and taught something. Okay, another fun fact. While I was in college at Texas A&M, I was on the university's country and western dance team. And so it was kind of a collegiate / professional dance team. So you could say that I'm a professional level country and western dancer, and performed all over the place, was on TV, performed in different countries, all kinds of stuff. So, and then I married a woman who was on the team as well. So now my wife can dance with my wife, and it's fun.
Nice. You should come to Arizona. There is a lot of country dancing, a lot of country places here, so you will like that.
Good.
I do remember my dad. I'm from Cuba, so my dad traveled to Canada when I was in high school, and he came back with a laptop that the hard drive was 1 gigabyte. That was the whole hard drive. And then when I was in college, we have a really huge book, ASP.NET, that it was just crazy. So for you verifying the code, you have to type everything that you saw in the book, and then it didn't compile. It was like crazy. And I feel a little young. My partner, Jose, that he's right there as well, he has been programming for like 25 years, something like that. So he also has these crazy stories when it's surreal. Like new devs right now don't know how good they have it. And I think like we always say that, but it's never a better time to be a .NET developer than right now.
Yes, but at the same time, people getting into programming today don't need to learn the languages and technologies that were there 20 years ago. Maybe they need to be aware that they were there, but don't waste your time with them.
Yeah, absolutely. Okay, so Jeffrey, I'm gonna let you take control of the session, of the talk. So go for it. Do you prefer questions at the end, or you're happy to get like interrupted at the middle with if anybody has a question or anyone want to?
Yeah, no, this is an interactive talk. So if there's a question kind of what I'm on, just jump in and ask. If you don't want to put yourself on microphone, then by all means just put it in the chat, and maybe Jose, you can help if there's any questions in the chat that need to be raised up. And yeah, we'll have questions at the end. I think that'll work great.
Perfect.
Okay, so you see the full screen, I suppose?
Yeah, we do.
Okay, fantastic. Well, I'm really excited to speak to the group. I think this is the first time that I've visited with your particular group, so thank you very much for the invitation. Today, we're going to go into Blazor architecture patterns, and one thing that I just want to give a disclaimer is I'm not going to introduce Blazor. I'm not going to show how Blazor works. I'm going to assume that you've already done a few quick starts, that you've created a Blazor application from the template, and you know the basics of how it works. There's so much out there that I'm just going to assume that you know generally what Blazor is. Instead, I'm going to talk about ways to think about patterns when you're doing your Blazor application, and hopefully help you sidestep some of the pitfalls and steer you in the right direction, and give you guidance on when to choose A versus B. And so that's my goal here. And so if I talk about some things that you're not familiar with, just take some notes, and I'm sure you'll find lots of content about how Blazor works in general, because we wouldn't have time to cover that just in this particular talk. As Jose mentioned, I do run a podcast. He's heard me on the podcast, and I ask that question all the time. So look up the Azure DevOps podcast in whatever directory you like. It tends to be the it tends to be the first or second listing. If you just look up Azure DevOps, and even if you look up Azure or if you look up DevOps, it tends to be in the first handful of those. So also, I like to kind of give away some free stuff at user groups. And while this is not specifically Blazor related, it'll help with any .NET applications, especially if you're running them on Azure. And I have, here's the book here, but if you are interested, and Jose, you can help me out with the muting of the microphones.
I'm on it.
But if you're interested, send me an email. There's my email on the screen, and I'd be happy to get a electronic copy of the book sent over to you. I can send individual copies to individual people. That's my deal with the publisher. And of course, you can buy it on apress.com or Amazon, wherever you like. All right, so let's get into some of the context. There's several Blazor projects that we've been involved in to different levels, and we're going to use lessons learned from real Blazor projects that are in production, and I'm going to highlight one that's actually in the Microsoft.NET Showcase. So if you go onto the .NET Showcase on Microsoft.com, it lists a whole bunch of different applications and companies and whatnot. And this is one where, if you just look for it, ClearMeasure helped a company called ShowWorks Cloud to develop a auction application. And this particular client deals a lot in county fairs, youth livestock auctions, where a kid raises an animal, brings it to the fair, shows it, they get the blue ribbon, the red ribbon, they get grand champions, reserve champions. And then if they like to, they can put the animal up for auction. And these grand champions, I mean, on the low end, a grand champion steer gets sold for $4,000, sometimes, $20,000. I think I saw a $12,000 hog get sold. And so it's a huge fundraiser for the education of kids that are going into farming, ranching, and agricultural in general. But the auction was very interesting because it was developed during the time when county governments were kind of shutting down and restricting people going in person. And so they needed a way to do this auction online. And so that created a situation where it wasn't just a regular application. It was a high intensity messaging application. And just think about when someone makes a bid, how quickly you need to see that dollar amount change. And so this had to be a very, very responsive application. And Blazor provided the ability, literally, to have a desktop rich application that was launched from a URL, where this just wasn't a web application where you go from page to page to page. You brought it up, and then it did different things and updated itself, and people bid and whatnot. So I'll reference that. And we also have a car auction application, as well as some others. But another picture of one of the modules of this county fair application. This is actually digital signage. This is a big screen. This is a big screen TV in an auction barn, and it's a full screen bit of digital signage. And this is another Blazor application, and it runs with no keyboard, no mouse, no user input, because that's what digital sign. You've probably gone to restaurants and seen menus that effectively are software applications. Digital signage is kind of taken over the world. But it receives messages from a control panel to switch to the next lot or update things and all that. And so this one happens to be a Blazor server-side application. Interestingly enough, just out of the box, it was compatible with Roku TVs, with Fire TV sticks, just plugged into the back of a screen. So to just having those smart TV capabilities, the basic browsers that come with these smart TVs and the dongles are enough to run Blazor server side. Blazor WebAssembly, not out of the box compatible because those thin browsers don't have WebAssembly, but they do have WebSockets, which is what Blazor server side requires. All right. I'm gonna go through some architectural ways of thinking, some things you need to think about when managing memory, how to implement hub and spoke patterns in your Blazor application, how to do UI eventing, then how to think about different levels of testing with your Blazor application, and finally, some unique things that you need to do when monitoring it in production. Let me set the stage for this Blazor application, and let me show you a highly shrunken technical blueprint for the flow and structure of a DevOps pipeline that, in this diagram, it's implemented with Azure DevOps Services and deploys with Octopus Deploy. It has a continuous integration build. It has a 3-tier deployment pipeline. And by the way, this is just the top third of the full DevOps architecture poster. And if you would like, by the way, the high resolution PDF of this, just send me an email. I'd be happy to send it to you. But I wanted to annotate where in your DevOps pipeline you need to do something specific because you have a Blazor application. And so you can see the little Blazor icon in version control, in packaging, as well as in deploying. And by the way, you'll never have fewer than 3 environments in your deployment pipeline because there's 3 different types of environments. Of course, you have production, you have a manual test environment, and you have a test automation environment. It's fine to have multiple production environments, just like it's fine to have multiple manual test environments. It's very common. It's very common for the development team itself to have an environment to do manual testing, for product management to have an environment to do manual testing. A lot of times for customers to have a UAT environment. That's fine, but you need at least one. And then the first one that I want to encourage all of you to put in place if you don't have it is an environment that is dedicated to test automation. I like to call it the TDD environment, to invoke test-driven development, but this environment allows us to complete the 3rd step in continuous integration. I work with a lot of teams that believe that they have implemented continuous integration, but they've only implemented one part of continuous integration. There's actually 3 parts. And by the way, I know I'm off course a little bit, but this is important for every application, not just Blazor. If you go back to 2006, I think it was, there was a book. It was published by Addison Wesley Press, and it was entitled Continuous Integration. And to this day, I think that's the best book that fully describes the tensions in the industry at the time and why we adopted continuous integration in the first time as a pattern, and described the pattern. And there's three unique stages in continuous integration. The book calls it the commit stage, but I think the common name for it now is the private build. And then there's also the integration stage where you have your integration build, and then there's your first deployment. So the first stage, private build, is completely on a developer's workstation with your own build script, and you're answering the question, I made a change. Is my change ready to be shared with the team, or did I completely break the application and it is not ready to be shared with the team? All right, that's the question. The integration build, it runs on a team shared server. It answers the question, with all the different changes of all the members of the team put together, do we still have a stable piece of software that's ready to be deployed somewhere? Or with all these changes put together, did something break? All right, that's the question. The third stage of continuous integration, which is your first deployment, answers the question, does this release candidate, which has a version, is the product of a build, does this release candidate still deploy properly? And does it still start? And so that's the purpose of the first deployment. If we haven't deployed it until we tell one of our constituencies, hey, we're deploying this on your manual test environment, well, then whoever we deploy it to first is going to find out when that particular build is broken. We don't want to waste their time. We want to find out for ourselves. And that's also the place to run post-deployment smoke tests to make sure that your deployment process is still working properly, as well as full system acceptance tests to make sure to test through the UI. All right, enough of that. In version control, there's one thing that you need to keep in mind for your Blazor application. Now, the good news is that for source control, Blazor doesn't do anything unique that is not also a part of .NET 6, but it's really important that you know this because you're probably creating a new application with Blazor. Put one Visual Studio solution in one Git repository. In this diagram, I call it put one version to software application. Well, with Visual Studio, one version to software application tends to be one Visual Studio solution. And you put that in a single Git repository. Don't put more than one, and don't try to spread it out across different Git repositories. Now, it's perfectly fine for your software application to be a part of a larger system, and that larger system is decomposed. And whether you're thinking, oh, let me go really small microservice style, or whether you're just decomposing a software system into, a number of applications. And it's perfectly fine for one application to have multiple things to deploy. It's very common to have a web application, which your Blazor inherently is a web application. You're also going to have maybe a SQL Server database to deploy. You're also going to have some sort of backend job, whether it's a batch job or a queue handler listening to Azure Service Bus. But so you're going to have one application, which is one Visual Studio solution, but you're going to have multiple processes to deploy. That's normal. But make sure that you include all that in a single Git repository, and don't try to have two different applications in the same Git repository. Every downstream tool for building and deploying and testing, it assumes that it's operating on all of the code that's in that Git repository. Okay, I'm going to glaze through architectural differences, but just in case you weren't clear on the differences between server-side and WebAssembly, I want to highlight the things that matter. All right, for Blazor server-side, when the client goes to your URL, the .NET process that's running on your web server is going to return back a JavaScript file. And that JavaScript file is the Blazor server-side client. And that JavaScript file runs in your browser, and it just stays there and it runs. That JavaScript file immediately is going to call back and open up a WebSocket with the web server, and then the web server starts feeding it information to change the screen. That's what happens, and it just sits there. So even though a user is clicking around and changing from page to page, and even though the URL keeps changing, you only have one web request that ever happens. Okay, that's what's happening. Your server-side Blazor application is running on the server. It is not running in the browser. And if you were to press F12 in your browser, you could see all these little tiny messages going back and forth. If you go to the network tab and then select your WebSocket messages, you can see just how many of these go through, and maybe you can recognize some of the text, like, oh, on render completed. That looks familiar. I heard word that the Edge team was working on a visualizer for these little binary messages, which you really can't see right now. I don't know the status of that. You might, if you like to check the Edge Canary builds, the pre-release builds, then you could check out to see what they have. But I heard that they were working on a visualizer for that. Now, WebAssembly, the DLLs actually get pulled over to the browser and actually run inside the browser sandbox. And so if you were to ask the question, oh, well, can I do this with WebAssembly? Can I do that with WebAssembly? The answer is that anything that you could do with running JavaScript in the browser, you can do with C# running in WebAssembly in the browser. If the browser would not let a JavaScript app do it, it's not going to let your WebAssembly app do it, because it literally runs in the same browser execution environment as React applications, as Angular applications. And so, no, you can't format the client C drive, but you can do other interesting things like, microphone, video, GPS, whatever APIs, the browser supports. Okay.
Hey, Jeffrey.
Yes.
Before we move to the app settings or the settings of the app service, we have a questions about the Git repo. So Jake is asking, like, their team, they have a template that contains several projects. So console, API, web, He's asking, shouldn't we have all of those in the same repo?
So that is perfectly appropriate for having in the same Git repository, because it sounds like it would all be one Visual Studio solution. You just have multiple things to deploy. You have a console project, an API project, a web project inside the same Visual Studio solution. And anytime something in there changes, you produce a new build, a new versioned build of all three, console, API, and web. If that's the case, yes, all that goes in the same Git repository, because architecturally, that would be the same application. It changes together, it's versioned together, it gets tested together, it's deployed together. So I hope that answers that question.
Perfect.
All right. Okay. All right. So let's go on to some settings that it falls under the category of just do it this way when you're deploying to Azure App Service. And as much as there is a whole lot of talk about Azure Container Apps and Kubernetes and Docker containers and running .NET 6 on Linux and all kinds of different ways to deploy applications and Azure functions and all that. Actually, if you go back and listen to Stefan Schackow and several others that work in Microsoft Azure, they've said on the podcast, I'll paraphrase, that App Service continues to be the most popular deployment target for all kinds of .NET web applications. I mean, it's not like an 80-20 rule or what it is. It absolutely dominates. So, there's other things that we'll see if they catch on, but App Service is drop dead easy, and it works so well that you really have to have a specialized environment to need to absorb some other friction in order to get some other gains. Azure Container Service Azure Container Instance, Azure Container Apps. There's so many names. That's the new one, Azure Container Apps, which is applying the App Service model on top of an Azure run Kubernetes cluster that you don't have to worry about. So I think that one is really interesting, because it'll be just as simple as the way App Service is now, but under the covers, it'll be Kubernetes. And so the only change that we will see that we will actually benefit from is we won't have to make scaling decisions one server at a time. We can make scaling decisions much more granularly, because we don't have to buy an entire server instance at a time like we currently do with App Service. But here's some settings you want to think about, because normally a app settings deployment starts out with the free tier and then you upscale it. Well, the free tier only supports 32-bit, and so you don't have access to more than 2 gigs of memory. And so you want to make sure that you change your platform to 64-bit. Otherwise, you're gonna quickly run out of memory, especially with Blazor server side. Went way too far. And so you also want to have your WebSockets turned to on. The free tier does not support WebSockets, so you want to intentionally turn WebSockets on if you're using Blazor server side, because it's using a built-in SignalR hub, which connects with WebSockets, and if it's turned off, it'll use JavaScript long polling, which you're wasting half of your CPU just because JavaScript long polling takes so long. And then you want to have ARR affinity turned on, because as soon as you scale out and add your second web server instance, if you don't have that sticky sessions turned on, then Blazor server side is going to completely break, because it's going to send users round robin or based on load. Whereas you want a user sent back to the same server instance that they started their session on, because that's where their memory is. Okay. All right. So just wanted to highlight a few of those. The sample solution structure for a good Blazor application, I wanted just to show you one. This one also uses the Onion architecture Visual Studio solution structure. For those, if you've never heard of Onion architecture, just do an internet search. There's tons of content on that. It's an architectural pattern that I first wrote about in 2009. It's been cited in several books. and whatnot, but you'll know it because there's a project called Core, and that's the biggest project in the Visual Studio solution. It doesn't reference hardly any NuGet packages. It is just your code, just your business logic code, your core entities, and the code that makes your app unique. Everything else just about is adapter code in some sort. And you can see, core.messages. If we have some messages that are shared with, in Service Bus or Azure Service Bus, we have data access that has that big entity framework dependency where we have to know about, database types. We have a database project for SQL Server database migrations. This particular project has an images for integrating with an image source for all the pictures of the cars in the car auction. And then we have UI, which is a Blazor application, and then UI.admin. This is another pattern, and regardless of Blazor server-side or WebAssembly, this is another pattern that I think is broadly useful because in so many cases, I mean, you could say, oh, there's no need for that in your case, and that's fine, it's your choice. But I've seen too many cases where a Blazor application needs to, do what it does, have a set of screens for its users, and then it needs a few screens, a few functions that are restricted by a super user or restricted to an admin. And we could tackle that problem by using authorization, using some permissions patterns, and say, you know what, unless they're in this particular role or in this particular group, don't give them access to these pages. Only certain users can have access to these pages. And that sounds good, but the level of complexity to implement role-based access across different pages is often more work than it is just to create a second smaller application that, oh, by the way, you can't even get to unless you're in that particular role. And so consider that pattern. And oftentimes also your main application is going to have very different scale characteristics, very different deployment outage windows, or not even allow those. And your admin functions tend to be more flexible because it's a very small group of users and they tend to only use it during their working hours. And so now you can have some more flexibility on deployments. Okay, let's talk about memory management. And I want to talk about scopes in the built-in inversion of control container, the dependency resolver. So Blazor uses the regular dependency injection container that's built into .NET 6, which kind of came from ASP.NET Core. But the difference is how the URL requests happen. Let's talk about Blazor server-side first. So no matter how many times someone clicks around in Blazor server-side, there is one web request. All right, that's key. So we'll come back to that. If you mark an object as singleton, no matter how many times you ask for its type, you're going to get the same instance of the object that was created, except only global to the machine. Okay. So singleton is one per machine. When you scale out and have multiple web server instances, you're going to get one per Blazor server-side process, which is one per web server, one per machine. Okay, so if you have 5 web server instances across your application, you're going to end up creating 5 of those objects. All right, that's clear. Scoped is when you ask for a particular object of a certain type, you're going to get one for every web request. Now, if you're doing a web API controller for a web service, then no matter, during the processing of any code in that web service, you're going to get the same instance that you asked for. And then the next time that web service is called and you ask for that same type, you're going to get a different instance. That's scoped. Remember, in Blazor server side, there is only one web request. So no matter how many users sessions you have running, you're going to get one instance of that object, no matter how many users have your application open, no matter how many times they click. And so effectively, if you only have one web server running, then you're going to witness the same behavior with scoped and singleton, because Blazor server side only has one web request. So it's going to appear like it's erroneously behaving like a singleton, but that's just because the architecture of Blazor server side. Transient, you're going to get a new object every time. Now, let's look at WebAssembly. For singleton, I mentioned for WebAssembly, for Blazor server side, if you have 5 web servers and you have lots and lots of users connected, you create 5 instances of the object, one for each web server. If you have the same application as WebAssembly and you have 5 web servers, but you have just tons of people connected, every single connected user is running a different instance of your application in their web browser. So singleton means scoped to the process. The process lives in the user's web browser. So every user is going to end up creating an instance of that object. Also, scoped is the life of a single web request. Well, in WebAssembly, there is one web request, which is to load the application, and then there's no other web requests. It's all running in the browser. So scoped and singleton operate exactly the same inside a WebAssembly process, no matter how many web servers you're scaled out. Then of course, transient, you're going to get a new object every time. Okay, so I wanted to go over those. Also, with Blazor WebAssembly, there's no concept of memory cleanup or session abandonment. As long as that browser is active, it's consuming memory, but it's consuming memory on the user's computer. Blazor server side is consuming memory on your server. And if a user goes away, then there's this little countdown for that user that starts up, and there's a 3-minute timeout. And after that, it kind of clears everything for garbage collection. But if a lot of people use their phone to use the Blazor applications, and if it's a Blazor server-side application, they'll put the phone away in their pocket, and then they'll open it back up. And the browser, the JavaScript client, the Blazor JavaScript client is actually pretty smart. It tries to link back up with the same session, and oftentimes it's successful. So memory for a user session sticks around for 3 minutes. Now, that is configurable. You can change it, but that one architectural detail makes Blazor WebAssembly very inappropriate for content management sites or blog sites or news article sites or just plain websites that are just informational, because those types of web applications, those types of websites, the normal usage pattern is for an anonymous user to find something in a search engine, to click over to it, to read it, and then go away. In that case, you're creating a full user session for that particular user, which is going to allocate some memory on the server, and it's going to hold that memory for 3 minutes. Now, you could allocate it down to 0, and that's fine, but you're allocating a reasonable chunk of memory for that session and then having to clean it up. And so if you have 100% bounce rate where someone's just coming, looking at it and going away, you're probably going to be better served just using Razor pages, using ASP.NET MVC. If you need something dynamic, consider using, if you need something dynamic in part of the page, you can make part of the page a WebAssembly application and make it dynamic. And only the first time they come to your site, they'll cache those assemblies. Now, if you have people who come to your site and then they never come back, well, you got to think about that as well, because bandwidth. All right. So if you're using Entity Framework, there is a bug that generated a bit of explicit guidance from Microsoft for the DB context for Entity Framework, because if you're now, Entity Framework originally is only used in Blazor server side because you're on the server, but with the introduction of the SQLite database able to be used in the browser, well, now you could just use Entity Framework in the browser against its local instance of SQLite. Now, you're not going to have your entire business database in that, but if you want to use the same programming model for storing a little, a smaller set of data just to be able to work with, then you might have a DB context in WebAssembly. But you want to make sure that you don't use the same, add DB context. Under the covers, it's just calling add scoped. And so that's going to erroneously use the same DB context for multiple different users' database requests, and that's not what you want. So there is a pattern for creating an explicit factory to handle that. And so I encourage you to use it. All right, let's jump to hub and spoke patterns. There was a significant period of time where a lot of programmers in the industry were doing page-based web applications. They were doing stateless web applications. I mean, if you think about it, going from 2004 all the way up to what, 2015, it's kind of over a decade. If you said, oh, I'm creating an application, a lot of people would just assume you were creating a web application. And if you said, oh yeah, I'm creating a web application, they would just assume that it was a stateless web application. And most of the time they'd be right. And what that meant is that we had effectively transaction script architecture pattern where we'd have top-down executed logic, the browser would receive some response, and then we kind of had to fake the creation of state. ASP.NET Web Forms kind of faked it with view state. Then over time, the industry and the users kind of demanded smarter applications. And so that's where the JavaScript SPA frameworks came from, is because the market was no longer satisfied with stateless web applications because they were just clunky. Whereas before, now half the programmers that are working in the industry are probably over that, don't remember what it was like to work with actual native applications until those same programmers started creating Android applications, iOS applications, tablet applications, and they realized, man, you can do so much more if you have a native application running on the computer, and it can have memory, and it can save stuff, and it can, and old timers like, yeah, you can. We did that, and so Blazor, it kind of brings that back. But guess what? It's a native application that can save and have state, but you can launch it from a URL. That's why everybody's so excited. Everybody that understands HTML and CSS, besides C#, really HTML and CSS, say, man, I don't have to use JavaScript, which is a terrible language. I mean, even the experts in JavaScript write books on the amount of the JavaScript language to avoid, and have a teeny tiny book called JavaScript, the Good Parts. And it's a really tiny book. So even the JavaScript people don't really like writing JavaScript. And with Google Angular, that's why they adopted Microsoft's TypeScript. And there's so many, anyway, I'll get off that soapbox. But with a native application, you want to implement some type of hub and spoke pattern. If you don't, then you're missing a pinch point, and you're going to write so much code. Let's say you have an application with 100 screens, each with a couple of buttons. You want everything that application does, every button click, every user interaction, to run through the same pipeline, run through the same abstraction. And so what you see on the screen is one example of that, where you create what's going to happen, which auction by event ID query. The user is asking for something. We're going to refresh data. And instead of calling a method on a class, which there's a lot of people that like using a repository pattern as a data layer. But the problem is, as time goes on, repository classes start accumulating various methods, and then it's unclear which repository class to put the next the next query method that sorts or filters by a unique way or gets joins two entities together. And if you convert to commands and queries, and whether or not you like pull aspects of CQRS or command query segregation, if you create everything that the user is asking the application to do into an object, and some people like to call them message objects, it kind of relieves the tension. And so what you see on the screen is a query object, and it just, because of the syntax, it's using nested classes. So new auction entry query dot by ID. Well, by ID is a inner class of auction. That's just a syntactic trick that this particular application happened to use. And it sends it down the bus, which routes it to a handler class that can actually run the query with Entity Framework. And then when that happens, we can also notify and send events that the entity was refreshed. Okay. All right. So that's something you might want to consider. If you look at the bus implementation in the car auction application, you'll see it's very, very simple. And it actually wraps the mediator library, which uses the dependency injection container to create handlers. And it's actually pretty simple. But then you have one class, this bus class, which can see literally every command, every query that's going on in the entire application, so you can do cross-cutting concerns. What's interesting with that is look at this publish method. After we do mediator.publish and route it to the right handlers, then we can also do interesting things like broadcast it across all the users. In the car auction application, when there's a bid that comes through, we need to broadcast that bid to every running instance of the Blazor application. And so what's great for broadcasting in real time? SignalR. And so we can route it in all kinds of interesting places just by having one spot in the application that can see every command and every query. All right. Also, application insights. One interesting pattern that really jumped off having one spot is to record custom events, where we take those queries, we take those commands, we take those events, we use the name of the type to create a custom event in application insights. And you'll see later on in the presentation the interesting graphs that's allowed us to do. All right. Also, consider this. This is not complicated enough to where you actually need to see some code, but when you have Blazor WebAssembly, the template that Microsoft gives you is that your Blazor WebAssembly code uses a web API controller for a web service to ask the server a very specific question. Give us the weather forecasts. And the pattern that's given is that every time the WebAssembly application needs to call back to the server, you would create another web API controller. Well, fast forward to an application. Now you got 100 screens, each with 2 buttons, or each with 2 things. You load something and then you allow the user to click something, do some type of transaction. So now every screen, 100 of them, have 2 things that it needs to call back to the server for. So now we're left with a situation where we have 200 web services. Now I'm ignoring how you might group them between, and have multiple on the same web API controller. I don't care about that. You still have 200 web services for a application that's not public. You're not sharing these HTTP APIs with the world. This is just for your WebAssembly application. Architecturally, you don't care about these web services. You're not going to layer on a Swagger UI. You're not going to make them discoverable. You're not going to manage the contracts and versioning of them, because the only client is the other project literally inside the same Visual Studio solution. So there's no need to do web service versioning. There's no need to do Swagger. In fact, there's no need to have 200 web services. When you have that situation, and you have your WebAssembly application talking back to your server, you only need one web service. You only need one web service endpoint that can receive all of the different commands and queries that are valid across your UI. So you see this hub and spoke way of thinking in the WebAssembly application extends across processes, across servers, across computers. And if you do it that way, then a lot of other things fall into place really, really nicely. And only managing one web service that can receive any type of queries that you have, any type of commands that you have, it's really easy. You can just serialize the body of that with JSON and deserialize it, and you get it across the wire, and literally use the same patterns that you already use with queues and topics and subscriptions with Azure Service Bus or RabbitMQ, and also SignalR. You take some type of object and you serialize it, you throw it across a queue or throw it across SignalR, and it's got to be serialized on the wire, and on the other end it's deserialized. But if you have 200 different message types, you don't have to have 200 queues in Azure Service Bus. You could send them all down one queue. So that's the difference between number of contracts or message types and number of unique transports. In web services, you only need one. You only need one transport for an unlimited number of message types. All right, let's jump into the UI, not the whole application, but just the UI. And let's dive into eventing. Your Blazor UI is stateful. Don't expect that there's going to be browser refreshes. There's not, even though you're going to fake changing URLs in the web browser, you're not actually asking the web browser to do another web request. And so any patterns that you happen to remember from desktop applications, bring them back, because they're all universally applicable. There was one pattern that's really, really common with WinForms and WPF, and that was whenever the user clicked on a button or clicked on something that had any kind of processing behind it, it was just a standard cross-cutting thing that it was kind of a wrapper. Before even going to the event handler behind that button, it would wrap a little bit of code wrapped in a delegate, and it would change the mouse cursor to the waiting icon, the little hourglass. And once the method that was called was done, it would change the mouse cursor from waiting back to the pointer. Now, most of the time, it was this tiny little quick blip because it didn't take long at all. But the times where we were calling over to another server and there was even, half a second that we were waiting, you had the hourglass cursor. And so the user immediately knew that, oh, something's happening. Okay, I don't need to click on something else. Something's happening. Do that in your Blazor applications, because if you click on something and the user's expecting something to happen and you're processing, but you give the user no feedback whatsoever that their click even registered, well, they're going to click again because they're confused. All right. Also, factor your screens into many components. Do not be concerned that you're segregating a particular screen into too many components. Do not be concerned about any talk of, oh, it's going to make the screen slow because it's just one screen and now we have 15 different components that are all loading with their own individual life cycles. Don't worry about that. If you do get into a situation where you have to do some profiling and that is a factor, then you have a very unique situation. And second, you factor screens into components, not for the software's sake, but for your sake, so that you can actually understand how many different things this screen is doing. And so logically map out what's on your screens and factor every individual thing into a different component, every logical thing. If a particular part of the screen changes for a different reason, it probably needs to be its own component. All right, so let's talk about UI eventing in this particular sample. This is part of the car auction application, and notice that at the top we have a subcomponent called refresh timer. Okay, refresh timer, and I'm going to jump into refresh timer, and this is the entirety of the refresh timer component. Notice that there's no HTML in this component, not a single HTML tag. Doesn't need it. This component is alive if it's on a particular screen, and its only responsibility is to wait a certain number of seconds as configured by whatever you put in the app settings file, and fire off a refresh timer triggered event every some number of seconds, whether it's 5 seconds, 10 seconds or whatnot, and just fire off an event that says, hey, refresh. Because there are some instances where something changed and it needs to be refreshed, along with the changes of pricing that are forcibly pushed. All right, so it's perfectly valid to have a component with no visible elements that only has a little bit of behavior so that it can send or receive some type of UI events. Now, other components on the same screen, in order to get that event, all they have to do is implement iListener of such and such. Now, this assumes that it's using a UI bus implementation, which, by the way, there's a library called Blazor MVC I'll show you next, which you don't have to make your own, or you can just use it as a reference. But this is UI eventing. And so all you have to do is implement the interface. And then, of course, you have to implement a method. That's the handle method. So we see refresh timer triggered. All we have to do is call whatever code we want to call. So if it's, oh, let me refresh the entries, or do whatever you want to do. And you can be an iListener of any number of UI events. So that is a really empowering pattern to use, because you are going to segment your screens into multiple components. And it's often, there's tons of questions on the internet with Blazor of how to do communication between parent and child components. Do not think of the relationship as parent and child. If you do that, you're going to create coupled code that's really hard to maintain, because what happens is, yeah, okay, parent to child, but wait a minute, hold on. In the way it's structured, the master page or the layout, the layout's kind of a parent of the parents, and we don't have a direct link there. And the parent that has the whole screen, or within the master page area, it's going to have a child, but wait a minute, that child's also going to have a child, and that child's going to have a child. And so that way of thinking quickly breaks down. Instead, you need to have any number of components that are alive register for listening as a listener on the bus for that screen, and then any of them can send an event through that bus, and all of the components on the screen will have a chance to receive that in their handle method, and they can do something. That is how you communicate between components on a particular screen. Don't try to do parent-child communication. It just doesn't work. Now, somebody's going to say, oh yeah, I got it to work. What I'm saying is, when you get to 100 screen applications all decomposed, it from a practical, maintainable perspective across a multi-developer software team, it doesn't work. Okay, so Blazor MVC is a library that I published just to give some samples on separating your controller logic from the layout in the view. Microsoft kind of bundles them together. Every generation of technology, we've had the same discussion. How do I separate the logic that makes decisions from the logic that makes it pretty? And ASP.NET MVC was a response from web forms where, hey, there was classes that decided what to do, and then there was other classes, the views, that decided how it should look. Well, in Blazor, they gave us a sample which has them jumbled together in the same file again. Now, yes, you can use code behind files and all that, but it's still compiled into a single object that shares the same memory. At runtime, these things need to be two separate objects. So I invite you to download Blazor MVC. Works with .NET 6, 5, .NET Core 3.1, Blazor server-side, Blazor WebAssembly, and it just gives you a way to have a controller component and a view component. And let me just give you an example. the counter controller that comes in the sample. This is segmented into a controller and a view, and this is what it looks like refactored. You have a class that now owns the route / counter, and it responds to the events. It does the incrementing, whatever logic is appropriate, and then the view only is what it looks like. And the only C# in the view is literally just properties so that the controller can tell the view what to do. The view doesn't decide, what it does on its own. All right. Let's see here. Okay, broadcasted events. So I talked about UI events. I touched on broadcasting in the bus, but this is a sample of how you can do it. If you have a broadcaster and you hook it into your main bus and send everything to it, the broadcaster can have, and your bus could do it too, but it's oftentimes easier for the broadcaster to control how to broadcast it. And oftentimes you will want this to be in a separate project that knows about SignalR, because you do not want a SignalR reference in your core project at all. You want to keep all of those libraries off to the side. And so you need to use dependency inversion to have an interface and then a class in a different project that references. So you can see we're using the hub context.clients.group. This is how we only send real-time push notifications to clients that are in a particular group. In a car auction, we don't want to send pricing updates to people who are currently looking at an auction in a different state. We only want to push the price updates to the people who are looking at the auction that just had the price updated. So that's one example. All right, let me jump into unit testing and integration testing, Blazor components. There is a Azure DevOps podcast on BUnit, and so you can look that up, the author of BUnit. But BUnit is a library that works really well with in-unit tests, ex-unit tests, and it allows you to create a Blazor component in memory in a unit test and tell it what to do, force it through its particular life cycles, and then interrogate the DOM with CSS selectors and make sure that elements are there or elements are not there. And so if you are not doing unit testing for your actual components for those classes, then you can use BUnit, and this is generally what it looks like. For your full system testing, Selenium is still what you want to use. Now there is Playwright that Microsoft is pushing that. I think it has the potential to unseat Selenium, but Selenium has been kind of the go-to for over a decade for any kind of web application in C#. But this is what a full system test using Selenium looks like. And literally you're just telling it, navigate to auction. These are helper methods. You don't want to have any Selenium syntax in your tests. You want them to read like English and call helper methods. But one thing I want to call your attention to, you see how there's multiple calls to Selenium test driver.take screenshot with a name? Every single time you do a particular task in your full system test with Blazor, you want to take a screenshot. And I'll show you a little bit later how those help you. All right. In full system tests, you also want to do some common setups. You want to operate your data layer and push some things interactively, push data into the database. You don't want to have this golden copy of test data. You want to have your test suite set up the data that your tests need. And so that's the way you want to run. And of course, every test you need to separate into arrange, act, assert. All right. But let me, let's see. I'm going to jump to operations. All right. Blazor server side is going to use more memory. more CPU. Okay. Blazor server-side benefits from low latency because of how many times it calls back to the server with these tiny little messages. For Blazor server-side, you want to use the V3 instances of servers. You don't want to use V2. V3 came out last November, and they doubled the horsepower for the same cost. And so, P1 V3, P1 V, or basically P1 to P3 V3. The P3, it's got 32 gigs of memory, 8 CPUs. It's kind of a beast. It's also $1,000 a month. P1 V3 is the smallest recommended server that the Azure team recommends you run a Blazor server-side app on, okay? Or its equivalent is P2 V2. Now, if you're using a WebAssembly app, you can run it on a tiny web server because that web server is only surfacing web services. And if those web services are small enough, then really it's just it's tiny. All the processing is on the client's machine. So very different. Now for monitoring, if you're monitoring a web service application behind a WebAssembly application, all the same stuff that you know about how to monitor those applies. If you're monitoring a Blazor server-side application, you want to look at 2 metrics right away and add these as the first ones on your application insights dashboard. You want to look at the server response time. You want to look at the average receiving response time. You want your server response time to stay under 10 milliseconds and your receiving response time to stay under 100 milliseconds. We found that if you stay under those thresholds, no matter what it's doing, the users cannot tell any discernible delay whatsoever. So those are the thresholds that we found out. All right. And then finally, I told you I would show you what factoring everything into commands and queries can do for you in application insights. This is a graph where by pushing everything as a custom event into application insights, you literally can see the type names of your commands and queries in the dropdown, in the filters, in the graphs, and you can have application insights plot them on graphs. And you could, like you say, submit new bid command. Now I have 5 of them selected here, but you could say, how often are people clicking this particular button that causes the application to do this particular transaction type? And application insights will gladly give you a graph on it. Then the little green check box on the top, that's the Azure Pipelines integration. That tells you when that application was deployed to production or the environment that you're paying attention to. So you can surface differences in metrics before and after you did a particular deployment to that environment, because oftentimes, maybe we want to change a particular metric, and you can add timings and all that. So that's really interesting. All right. So to recap, there's a lot of information. My email address is on the screen if you want the poster, if you want the book, if you have any questions. Just send me an email. I love to, go back and forth and get to know people that I haven't met. And so I'll kind of leave this slide up while we're doing Q&A.
This was an awesome presentation, Jeffrey. There is a lot of information there, and I have to attest to a couple of those things. So after your podcast about Blazor architecture, in my team, we implemented the circuit tracking, and we put it on application insights. It's a beauty. We have so much information right now. The hub pattern, that we have everything in just one hub, that's something that I'm looking forward to finally completely implement. So I think that I talked with you about, I think that at some point, one of the things that I want to do for the community is put a sample with all these recommendations that are really good, the controllers, the hub pattern, the circuit tracking, and put everything out there in just a sample so people can go from there and just use it. I think that the controller gives you a really the copper way to handle your application. So And I definitely will be sending you an email to get the HD definition of the DevOps completely picture of all those steps, because that's really, really nice information. So we have a question from Jose that is, for the MVC pattern, do we need an external library? And I think that you presented the Nugget package that.
Yes, but I'll show you if I mean, do you need an external library? Yes, just search for Blazor MVC on NuGet, but also let's see, NuGet.org, Blazor MVC. You can also go to GitHub and just snag the code and just put the code in directly if you want to. Blazor MVC. Okay, in the source repository, it's linked directly there. So there's a bunch of samples. I mean, if you're in a situation where getting new libraries approved is a problem, I mean, you can just snag the code and, you know, put a little license comment at the top, and it's not a tremendous amount of code. I think that the one tricky part, and this is, you don't want to figure out how to implement this yourself, is around render fragments, because the controller takes the view and makes the view a child. So the controller doesn't have any visual elements, but it has control, and it executes first. And then it decides what view to use and when to use the view. So it totally wraps the view, and the view becomes the visual elements. And so we use the render fragments and the render tree builder to take the view and do the embedding. So that's the little bit of tricky code that you get for free by using the library. But do you have to use this library? No, you could go and learn how this code works and kind of adapt it and change it. But I like libraries, so I don't have to think about it. But there's the code, so you can kind of see it for yourself.
Nice. The other thing that I think that it was really good that you mentioned is, like, I have seen a lot of new devs starting with the free tier of DevOps of Azure, and then when they start doing a production application, they forget that the free version is 32 bits, that the free version doesn't have WebSockets on, and then just by turning those on, they see a huge performance improvement in their application.
Yep.
All right, guys, if you have any more questions, this is the moment. I'm really excited about this talk. I think that we will be recommending, like, one of the things that one of the recommendations that we got from you is, like, everyone in our company that start working with us, we made them watch Blazor train beginning to end. After that, they are good to go to start developing. So I think that we're going to add this video to that training materials for all our new devs.
Yeah, you mentioned Blazor train. Carl Franklin does those. Actually, there are some new hires for ClearMeasure. We also assigned them to watch the Blazor train videos. Those are super fantastic videos.
They are really good. They are really good. We have another question that Tony is asking, like, is there any sample of Blazor WebAssembly and course backend?
So I've presented exactly one talk on that. I just touched, kind of described it here. And I don't believe that code is public just yet. I intend to. So whoever's interested, just send me an email, follow up with me, because it's on my to-do list.
Sorry, I was a bit. So actually, Jose and myself, we were in the last Blazor roadshow. So they start doing the Blazor roadshow. They went to LA, and after that, COVID hit, and they moved to Blazor train. So we were in the last one there. So that was really exciting. Okay, guys, if there is no any more questions, I won't take more time from Jeffrey. I really appreciate he taking his time of a Thursday night to talk about us about Blazor. But I have to say, like, Blazor right now is the new kid in college, but it comes with so many good things. So I'm really excited to be learning more about it.
Well, I will mention, since you guys have done so much content around Xamarin and then Maui and whatnot, we have proven architectural prototypes that Blazor embedded inside a WPF application is for real. Microsoft has talked about it. I'm sure that they'll talk about it more at Build. It is for real. It works. Imagine this, and so many web applications would benefit from this. You know, Dropbox and Google Drive and OneDrive and all these little applications have their system tray applications. That's where they live. And if you click on the icon in system tray, they'll pop up a little mini screen or a little menu. Well, out of the box, you can create a little tiny WPF application. And the only thing WPF about it is the icon in the system tray, and then a little bit of code that routes notifications to the Windows Action Center. So you have Windows notifications and Windows pop-ups. But if you double click on it, it is automatic, where you can make every screen in that application a Blazor screen. And it's not Blazor WebAssembly, it's not Blazor server-side. When you put it in WPF, it's Blazor native. It's running as a Windows application. So if you were an administrator, yes, you could format, you know, or you can't format your own C drive, but you could format a D drive or something. You know, it's native C#. Also, Maui tooling is not yet prime time, but the Maui runtime is real. I mean, it's working great. The emulators inside Visual Studio, they are still working out bugs, but the vision, and I really believe that they're getting this right, that with Maui, we get all the power, we inherit all the power of Xamarin to create Android and iOS native applications, but every bit of the user interface can be a Blazor component. Therefore, we get a native application, but anybody that knows how to do HTML and CSS and Blazor components, now they're a mobile developer.
Nice.
And it's real. And so when Microsoft, you know, pushes it out as GA, the Blazor UI, the Blazor application, mark my words, is the new normal .NET application for wherever your application is running.
I completely agree. And if you see the new templates from the Microsoft Teams are in Blazor. If you see the Blazor in Maui, that's not running WebAssembly. That's some interop similar to Blazor Server that they are doing through JavaScript. If you see the Blazor Web View in NetConf, they throw it out with WinForms, and now you are just proving to us that you did it on WPF. Blazor Web View, I saw someone in the community that they throw some Angular at it, and it took the Angular. So everyone who knows some HTML, CSS, and know how the Blazor components model works will be able to do, as you say, every spectrum of the .NET development. That's just like, I get goosebumps. And we actually put it on Electron. So we actually did an Electron application with Blazor. So basically, if you think about that, it's web, desktop, and mobile, everywhere.
Yeah, and we have a client that has a 25-year-old Access application, Microsoft Access. I mean, you look at it, you can't tell it's Access. It's been just customized. It is a custom application, but it's on top of Access forms and everything. Over the years, they've done a lot of little screen add-ins that run little bits of JavaScript, Ajax, and do all kinds of stuff. And we're in the kind of architectural planning stage, but Blazor can run anywhere that you can do modern JavaScript and server callbacks. So that we're in the planning stages for using little bits of Blazor inside this really, really old Access application, because architecturally, you just need to be able to run reasonably modern JavaScript. That's kind of the requirement to be able to run a little piece of Blazor in any kind of existing user interface.
Nice. I just want to mention two more things. So I have seen clients of us using MVC with Blazor components already, and it's not hard at all. And I have seen the other way. I have seen Angular applications starting to migrate to Blazor, but they don't have to migrate at once. They are migrating little components by little component. And I think that Microsoft showed an example that it was a to-do list where the to-do list was in Angular, but every to-do item was on Blazor. So it was just very crazy thing. So Jeffrey, we have someone else in the meetup asking for your Twitter handle. So if you can show that one so they can have your information as well.
Yeah, sure thing. Okay, it's right there.
Right there.
At Jeffrey Palermo.
And for everyone here, remember, if you want a copy of the book .NET DevOps or Azure, please email Jeffrey. He's happy will send you a copy of that.
Yes, sir. Yes, sir.
I'm really excited about Blazor. I do believe Blazor is the future, and we need to get in that wave for sure. Okay, thank everyone for joining up. We're gonna see you next month. Next month, we're gonna try to talk about Avalonia, and hopefully we are able to get Jeffrey back in the couple months to see what is the state of Blazor with Net 7 and everything that is coming, that I think that is really promising.
Yeah, happy to. Look forward to it.
All right, thank you, Jeffrey. Thank you, everyone, and see you next month.
All right, thank you all. Have a good night.
Bye.